Hello, it is I, Dr. Brian Lorgon 111, coming at you again today for more of my kind of code walkthrough of Vanilla Swirl CTM. And to start things off today, I wanted to cover the Green Beacon dungeon. And I was taking a look at the code. It's about 400 lines of code, and it's just too complicated to try to walk through the code. And so instead, I figure let's actually go over to one of the green beacons and talk through things in Minecraft. So here we are at one of the green beacons in the map, and it starts out as kind of the same thing we've seen before with cave algorithms in terms of I do connected components of airspace in order to kind of like figure out what an entire cave system looks like. And then in order to decide if something is going to be an appropriate place where we could put a green beacon and have it eventually, go down through a crazy path to get down to a loot box like the one that we have over here. It goes and it tries to find the shortest distance from the place on the surface where the cave entrance actually begins down to somewhere at the lava layer. And it makes sure that that path from the top down to the lava layer covers at least, I forget if it's like 350 blocks. I forget what the length of the green beacon is. But it makes sure it's some minimum length, and then we could start at the surface and get down to a bit of the cave that's at the lava layer. I think it goes down to like a Y that's at most at least 20. And so we can see this one's like ending, right down by the lava down here. And so then we have kind of a path through the cave. And it used to be the case that it just like picks the path from the surface down to the lava, and I would try to choose like any cave I could find whose longest path down to the lava was anywhere in the range of, I forget, like 250 to 450 or something like that. And that ended up with way too much variability. And so now I just make sure that it's like at least 350, and then I like truncate the path at like 300 blocks or something. I don't remember exactly what it is that I'm doing. But it used to be the case back in the March maps that like some green beacon caves would be like 2 or 3 times more difficult than others. So once we have that path, then we're going to take the main path, which is the one that actually, has the redstone ore here. And basically, the path that it actually finds is just kind of like a single block path that's kind of like floating through the airspace in the middle of the cave over here. And we can actually see when this one goes down to the ravine, basically, well, let me talk through it in one of the narrower bits of the cave. So back over here, let's do this. Let's get into creative mode. And then, of course, that's going to cause monsters to start spawning. And so let me go ahead and also set the difficulty to peaceful, so we don't have to worry about monsters spawning anymore. And I've got the infinitely seeing eye to give me night vision, but I think it'll be easier because I want to actually place some blocks to go ahead and just give myself night vision this way. And basically, something like this is what it sees as the path that's, running through the cave system. It probably goes something like this. And then as it comes around here, it probably, goes down and then goes around corners and does whatever it does. Well, it's not exactly like this, because it would actually be over here. But basically, it's got some path that's kind of like hanging through the airspace. And it does 2 things along the path. One is from each place in the path, it goes and drops straight down until it reaches the ground, and that's where it puts the redstone ore stripe. And so that's why, for example, when we're in the ravine, you'll see these places where it jumps and it's on this level, and then it just falls down to over there. The actual path is actually still kind of like at about this height or something, kind of moving through the ravine. It's actually probably up here, but it's just dropping the redstone all the way down to the floor, and that's where it actually places the redstone ore. And so when you see the Y values of the redstone ore path change dramatically, that's kind of the reason. It'll become a little bit more clear as I talk about the other bit too. And let's see, where was I placing the glass? Back up here. So that's how the redstone ore gets placed. And then the other thing is, yeah, say we're at this particular block. It's occasionally going to try to place spawners in the wall. And so what it does is it just starts the block that you're at, and it moves outward one in all directions and says, have we reached the wall yet? And in this case, the answer would be no. And so it keeps moving out in one direction, or one block in each direction again. And so it would start looking at all these blocks that I'm kind of breaking in the wall over here, including where that spawner is. And it'll say, have we reached the wall yet? And in this case, kind of all of these points and all of these points in the floor that I didn't go and actually replace are places where it would look and say, yes, there is wall there. And then it says, okay, from all those different wall spots that we just intersected, select one of them as a candidate to replace with a mob spawner. And so in this case, that's how this ended up becoming a mob spawner. And so as we go down the tunnel, there's kind of like an increasing probability, like it starts with a low density of spawners, and the farther along the path you get in, like, you know, every 5 or 10 blocks, it like increases the percent chance of a spawner in the wall by 1 or 2%. And so as you get farther in and farther in, the spawners start becoming more and more dense along the path. And when you get out to a big open place like the ravine cave over here, you can actually, based on where the spawners are, you can tell where the actual kind of path that my algorithm thinks is going on in the cave is. And so it's something like up here, because all the spawners are up here at this level. And so once again, it's like going along this path and saying, where's the wall? Where's the wall? Where's the wall? And then it finally intersects over here. And so decided to put a spawner right there. Or as we came further on down the ravine, it says, you know, it's looking for the wall and found wall intersecting over there. And so it dropped it down there, even though the redstone path is way down here. And I found, like, this was kind of an unintended side effect of how I ended up implementing the algorithm, but it ends up being good with the redstone path down here, but the spawners kind of actually being above you in a ravine. You end up with monsters kind of falling on your head, and so you end up having to, you know, climb up onto some of the ledges of the ravine in order to break the spawners, but also be looking down in order to see where the redstone paths are. And so that's pretty good. And yeah, I guess over here the airspace was a little bit higher up, and so we ended up with all of these spawners up here, and the actual path that it was following was probably high up because it was coming through here, and so it was like staying at this height and staying at this height, and the next place that it wants to go is up higher, and so it never went all the way down to the floor, and so this is why most of these spawners ended up in the ceiling in this particular location. And so yeah, just kind of side effect artifacts of how I implemented this. Ended up creating some actually kind of like interesting ways to place the spawners. But when you're in a narrow tunnel like this, basically it's going to find walls all around you, and so you'll end up with the spawners kind of all around you. I biased them a little bit to the floor rather than the ceiling in most locations, because originally this was something that was in some of the alphas that I had. It would place spawners in the ceiling where they couldn't actually spawn any mobs because there wasn't enough airspace, and so it prefers to place them kind of like on the lower half rather than the upper half when it has multiple possibilities. But then you finally get to the loot box, and we just place a loot box at the end that has the loot. And in the particular case of the green beacon, and we've already kind of passed by it in a few spots over here, in addition to doing this main path, it also creates side paths. And so when there's branching bits of the cave, we already have the main path that's going over here, eventually toward the loot box. But when the cave branches, it will also send off kind of little path feelers to try to find dead ends, where it can place one of these dead end turn back and try again chests that give you some emeralds. And that both makes exploring the cave a little bit more interesting and exciting, as well as more dangerous, because even though there aren't spawners along this path, while you run over here and spend a little time finding that this is a dead end and getting your emeralds, you might still be spawning some other spawners that are kind of like through the wall in some adjacent section of the cave. And this whole thing of finding the paths and finding the side paths is incredibly expensive and convoluted to kind of like go and compute, and has lots of little bugs, and pretty much in every release of the map, even just going from, you know, May ABC to May E to May X or whatever, like I've been fixing more and more bugs with this, and so it's kind of improving, but this is the part that is most algorithmically complicated and was one of the first things that I ended up working on. And so the cold code is also the oldest and the code is kind of rotting. And so this is one of the reasons that I've been playing around with trying to engineer my own cave systems. And so I've at least been toying with the idea and doing a little bit of trying to generate caves that are like Minecraft, but that are actually my own caves. And so I can have them have as much branches or as few branches or go in whatever directions that I want them to go, but still have it feel like Minecraft caves. And so maybe eventually I'll make another map where I place all the caves myself, and then I won't have to do such complicated math to try to infer the structure of the caves and try to figure out where to place things, because I'll be exerting more control and I'll be able to, have exactly the number and types of branches and length of the cave that I want in order to do things. So in any case, I'm not showing any of the code here because the code is complicated, but that's kind of an idea of what's going on in the green beacon. Next up, I want to talk about the random loot chests that are hidden throughout the map, such as this one that Cthulhu and Sarkaz and I did not manage to find. But the eagle-eyed viewers, I'm actually in spectator mode here, and so you might actually see the armor stand kind of peeking out right over here. But basically, we have a flower that shouldn't be here. This type of flower doesn't generate in this biome typically. And there's a circle of tall grass around it. And if we take a look down here, there's a loot chest with random loot. Hooray! And there's lots of different types of random loot chests in the map, and the code that places all the random loot chests is actually like 700 lines of code, but despite being a lot of code, there's a lot of little simple parts, and so let's actually jump into some of the code and get an idea for how I place some of the random loot chests throughout the map. So first up, we have just some of the kind of helper code that's in the random loot chest kind of overall algorithm. There is put trap chest with loot and put furnace with loot, because I place both chests as well as there's a furnace that can appear next to a lava pool. And this basically just says what kind of loot is going to go in each one. We saw in a previous episode, there were loot tables. There's 3 different types of what I call the aesthetic loot chests, the aesthetic tier 1, 2, and 3, that originally when I was making this, I thought some loot chests were harder to find than others, and so I was going to have some have better loot and some have kind of like less interesting loot, but more it's just kind of overall variants of loot right now. Now that there's the loot finder kit, you should be able to find all of them if you're looking. And yeah, the code here isn't too interesting. Let's move on to the kind of main algorithm that drives most of the random loot stuff, which is, like a lot of the different algorithms, it walks pretty much over the entire map. And so I walk over all the X values and all the Z values. And the Y values actually go from 90 down to 59 because it's surface loot chests that we're trying to place. And so I just kind of like look mostly at the surface, typically sea levels around 64. And so 90 down to 59 is pretty much kind of on the surface. And there are 2 things that I try to stay away from. Decorations are basically places that I've already noticed that I've put something on the map, like dungeons. And I don't want to put, some kind of random loot chest inside the cobwebs of the red beacon, for example. And so basically we stay away from any of the existing decorations. And so we'll stay away from all the existing dungeons that I've placed. We'll stay away from the teleporters that I've been placing around the map, and whatever other bits have already happened kind of earlier on. And I also stay away from spawn. And so I make sure that the absolute value of X and the absolute value of Z is greater than 25 to not put anything that's right near spawn, because in some of when I was originally testing things, like you'd have the spawn platform where you had the monument and the books that tell you how to get started, and then like 2 blocks away there would be a random loot chest. And that feels a little bit weird. I should probably even increase the distance of this a little bit more, but it's fine. So basically, I'm looping over the entire map, and then, for example, if you've seen in the Mega Taiga, there's like those moss stone boulders, and occasionally there's chests on top of that. And so here we see the code for that, where basically, as I'm walking around, I look and see if I find a piece of moss stone, which is block ID number 48, is how moss stone is encoded in the data files for Minecraft. And check for plus is a little function that if you imagine a 3x3 square, it will look for one block in the four corners, like upper left, upper right, bottom right, and a different block inside the kind of other five blocks, the plus sign in the middle. And so this will basically look for a plus sign of moss stone with air on the four corners, which is what the top of one of the moss stone boulders looks like. And if we detect one of those, then there's some random chance that we'll end up deciding that this is a good place to put down one of these loot chests. And we'll actually just go and put the loot chest there. And I also check if none are within 50 blocks of it. And so basically I don't want to randomly put two of them right next to each other. And so almost all of these random loot chests have some certain spacing from other instances of that same type of loot chest. I'm not going to show the code for all the different types of loot chests because some of them are much more complicated than others, but here are a couple more simple ones. The first one, else if the block ID is 100 and the block data is 5, that happens to be 100 is a red mushroom block and 5 is the data value for a red mushroom block that only has red on the top and has the other sides being kind of like the grayish mushroom texture. And so that would be the top center of a giant red mushroom that you'd find in a roofed forest. And there are treasure chests hidden inside there. And so there's a 1 in 3 chance that I will take a look at any given one, and if there aren't any other red mushroom blocks where I've already placed a loot chest within 120 blocks away, then I'll go ahead and put one of my loot chests in this particular location. So that's the first bit of this code. The other one there's actually a few different things where I start by looking for grass blocks, but this particular one, at the very bottom, you can see the name of it is Forest Buried. It's basically where I find a 3x3 patch of grass that has air above it in a forest. And in that case, there's a small chance that if there aren't any other nearby chests, that I will hide a chest under the ground and I will cover the top with coarse dirt. So basically you'll have all this grass and then you'll just see like a coarse dirt patch where it's brown rather than green on top. And if you go and dig in the center of there, you'll end up finding the buried chest there. And so basically, yeah, it just looks for a 3x3 area of grass that has air above it. And yeah, some of this code kind of got cut off to the right. I think I mentioned this in a previous episode, but I'm doing screenshots of the code rather than scrolling around in the code because when you do video of text, if the video moves around, like the text tends to get blurry and be hard to read. And so doing screenshots seems to be a better way to just have the video quality so you can always crisply read the text that's on the screen. All right, next up, one of the ones that I just showed in Minecraft is the ones where I find a 9x9 area of grass that's flat, and I place the flower in the center and then either a circle or an X of tall grass above it. And so I don't have all the code here, but this just gives you an idea. Basically, there's a 50-50 chance there's an if-then-else where it either makes a big X or a big O of tall grass. And basically, yeah, I will go and put tall grass at certain locations and air at all the others above this flat patch of grass. And then right in the center, I will pick a random flower type. There's, yeah, I guess 9 different flower types, you know, the oxeye daisy, like the 1 high tall flowers, the poppy, the 4 different colors of tulips. I don't remember exactly what all the different flowers are, but it picks a random one of those and puts that in the center. And then it has this kind of tall grass decoration around it to also make it stand out. And then just places the chest right underground. And so that's another one of the random loot chests that it goes and finds after it locates. The code for this is off the top of the screen, but after it locates a 9x9 kind of flat area of grass. Here's one other one that I figure people will want to see, the one that's hidden in the swamp, and you can kind of see over here already. But with the invisible armor stands, they're a little bit hard to see. If I do entity data at e type equals armor stand r equals 20 invisible :0, I believe that'll make them visible again. Yeah. And so you can see the armor stands there that say dig with the X, and the X is right above where you actually need to go and dig for things. And so yeah, I'm not going to show all the code for this, but I'll at least show you some of it. So let's go take a look. So to start things off, we have kind of the pixel template for what I want to draw, and I think it's like 11 by 11 or something. And then what is the code doing? It is looking at the biome to check that it's a swamp. It is looking at the block info to check that there is water with air directly above it so that we find kind of the surface of the swamp. It is making sure that we are outside of the daylight radius because you're only going to find this if there's, mobs wearing the Frostwalker boots, and they're only going to appear at night because they won't spawn in the daytime. And it makes sure that I haven't already placed another one of these within 120 blocks, none within 120, because I don't want to have, like 2 of these right next to each other in a swamp. And yeah, and so basically it goes and looks for like this 11 by 11 area of something that's in a swamp and has the water surface with the air right above it. And then I will skip down a bit of the code and just kind of like go to the end. Once we've picked the location and place the armor stands then in that pixel location, it knows the X and Z where we want to place the chest, but it has to like figure out where to dig underwater. And so basically, while it's water, we keep on stepping down. Y gets Y minus 1, down, 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 until we're no longer in the water, which means we've reached kind of the bottom floor of the swamp where it becomes dirt or stone or whatever. And we go a couple blocks down from that, and that's where we actually place the chest underground. So you have to like dig underneath the bottom of the swamp. And then we need to make random skeletons and zombies nearby have Frostwalker boots that they're going to drop. And so there are a couple of command blocks, one for zombies and one for skeletons, that basically go and entity data, which changes the data of entities. You just saw me run that to make the armor stands visible, but you can also use it to change, for example, the... is it entity data or replace item? I guess it's entity data. Again, the code is cut off on the screen over here, but basically I go and I actually give the mobs Frostwalker boots that they will drop 100% of the time, and those are just running inside repeating command blocks. And so if the player is in this area and there is a skeleton or zombie nearby that we haven't already seen and tried to update, then it will go and give the mob Frostwalker boots. And then there is code down near the bedrock at the very bottom of the map that basically is detecting all of these armor stands and detecting any that end up having frosted ice. It's kind of like the third line from the bottom. It's getting caught off on the right, but it's detecting frosted ice. And if there's frosted ice there, it's going to change it back to water, basically, so that area doesn't freeze. And so when you or the mobs walk over this area, you'll frost all of the ice except for where those spots are. And there's some code that also, like, I skipped over that basically makes sure there aren't lily pads in the way, because the lily pads can kind of make it hard to see the dig, and so it clears out some of the lily pads nearby and different things. And at the bottom, the add tile tick on the repeating command blocks, that's basically the thing in the save file that says that this block is scheduled to run the next tick. And so, if you save and exit a world and there's a command block that's supposed to run the next tick, like there's a tile tick for that command block, is what's going on there. So I don't know how well I explained that, but the code overall is a little bit longer and more complicated, but that's kind of a quick summary. One more type of chest that we can quickly show off the code for, you might recall when I played with Cthulhu and Circaz. Cthulhu went over to chop down a tree and found a chest underneath it. And if you take a close look at this particular tree, it's a spruce tree, but the bottom log is acacia wood rather than spruce wood, and that's what tips you off that there's actually a chest hidden down here. It's just another one of these random loot chests. And so let's take a look at the code for that. So you may recall previously that I already have other code that knows all the trees in the map. And so basically I randomly shuffle through all the trees in the map. I'm going to skip over any that are in the hell and end biomes where I've already replaced the trees with like the netherrack trees, the end portal frame trees. But among the rest of those trees, I look nearby and see if there's any other common chests nearby, because I don't want to have whole clusters of loot chests that are really near to one another. And then I also make sure that at the stump of the tree, like the block underneath it, it's not the case that the tree is like sitting on the very corner of a hill, and if we put the chest would be kind of like exposed to the air. And then once I've chosen a particular tree, I basically just go and replace the log that's at its base. And so acacia trees get a dark oak base, oak trees get a birch base, and all the other tree types get an acacia base. And so if you happen to be looking at this tree and notice that the stump is the wrong type, you'll be able to see it, whether it's in the daytime or the nighttime areas of the map. Or if you have the loot finder kit, it'll eventually direct you to one of these trees. And yeah, we just go and poke the log with a different data value. So we've got a different type of log there and put the trap chest underneath. Pretty straightforward. Finally, one other bit that I can quickly show you the code for: when you get the mountain peak loot and you get the mysterious divining rod, which is the thing that points you in a particular direction, and so as a result leads you to the blue orchid where the elytra chest is. I think also I showed this off in a previous video, but just as a reminder, once you reach the top, it says dig here atop the mountain once you actually reach the location that you're looking for. And if I were to go down to the bottom of the map, and then if I were to fly down to the very bottom of the map, so it's right above me right here, on the bottom of the map, it looks like this, with these pretty color rays kind of emanating from this location that has glass right here in the center. And so with that little refresher, we should be able to understand the code for place compass commands, which is what does all the logic for the divining rod. And so basically, hidden X and hidden Z is the coordinates of the elytra chest and the orchid on top of the mountain. And so basically, I can compute at any point on the map, given its particular X and Z, I can compute kind of like how many degrees, like which direction you need to turn and look in order to be kind of facing that direction. And I basically divide it up into 32 different sets of degrees that are each about kind of 11 degrees wide, and then choose one of 32 different colors, either 16 colors of stained glass or 16 colors of stained hardened clay, that we put down at level 1 of the map. Or level 0 of the map, I suppose, and at level 1 of the map I place some bedrock right above it, and so it's, you know, at the very bottom of the map, and so the player can't actually dig down there. And also right at the very center, the 3x3 area of blocks that the elytra chest is actually hidden in, or whatever, I put normal glass rather than stained glass. So then moving down to look at the next bit of code, we have the actual string that appears, you know, on the heads-up display, depending upon exactly which way you're facing. And so I actually take that big long string that has all the possible characters that it can display with the arrows. I double it so that it's twice as long. It's the same string repeating. And then I just figure out a particular index of where I want to start in that string. And then we actually need to see if there are players who are currently holding this item. And if so, then we need to figure out where they're standing, and we're also going to figure out the player's rotation. And so basically, the read the world data is going to detect all of the 32 different types of blocks that could be below it in order to figure out what its rotation is. And so 6, 17, 28, 39 over on the bottom right there are basically different degrees of rotation values, depending upon what color stained glass is down at the bottom of the world. And if I move on to the next screen, then we also need to detect the player rotation. And so I summon an armor stand, I teleport it to the player, which means the armor stand will now be facing the same direction as the player. And then I can test for the rotation values of that armor stand and give it a particular score and add it to the degree score of the color of the glass that's down in the ground. And then modulo that by 360. When I say convert score to title text, percent equals 360 is basically going to convert it into degrees between 0 and 360. And then depending upon which degrees value we get, shows us which value of text we're going to get for where the arrows are exactly pointing. And that goes on for all the possible different values of degrees. And then if we go down to the bottom of the code, it also detects glass. And if so, instead it puts up the text that says dig here atop the mountain. And yeah, that's pretty much it. And then it has a bunch of command blocks basically at spawn that are all these commands that we just saw the text for. And so there's like, 100 commands to do it, but in principle, it's pretty easy. And most of the commands are just 32 different versions of checking all the 32 different increments of the rotation of the divining rod text that appears. And so again, the text that appears in the heads-up display, it's basically one long string, and after I do the math on the rotation, I figure out where to index into that string to figure out which set of characters I'm actually going to display on the user's little heads-up display using the title command. But that's it for today. We've actually gotten through most of the interesting bits of code. There's still a little bit more code I'll probably talk about in a future episode, but then I'll also talk about just some of the overall process I use in terms of creating and selecting seeds and different things like that. In any case, I hope you're continuing to enjoy this series. I hope you guys are having a great day, and I'll see you again soon with more Vanilla Swirl developer commentary, where I talk about all the gory details that went into the making of this map.